Okay. We can start a little bit of chat for our popular talk. Let's talk about you, Hane. Would you like to introduce yourself, first of all?
Yeah. Thank you so much. Thank you so much. But make sure that to make me a co-host for on the other account.
On the other accounts, writing Dali, right? The only one.
Hani Dali, yes. Hani Dali.
No, the other account says only Dali here.
Okay.
Right?
Okay.
Okay.
Yeah.
All right.
Done. Great. Okay. My name is Hani Ad-Dali'. Dali' means thorough in Arabic.
Before you start, we still have 4 minutes, so take it slow before you start your presentation, okay?
Sure.
Okay, we're recording.
How many minutes do I have?
Yes, about 3 minutes. We can start chatting, but before you start your presentation, please, let's wait for 3 minutes. Okay.
I mean, my presentation, how long is it?
How long it's gonna take? Well, maximum 50 minutes.
Maximum?
50.
50. Oh, too much.
Too much. You don't need that much.
I will finish in less than that. In less.
Yeah, sure. Okay, that's better than people can have some dinner.
Okay. Yeah. Don't worry. I will go very fast because I'm doing some presentation about the applications of Astronomy. It's okay. It's okay. So we still have 2-3 minutes now.
Okay, I remember you were an attendee, participant in the first Azarquiel school. Am I right? Was it the first Azarquiel school?
And I remember when you prepared 100 telescopes, I believe.
Yeah, that was 2009.
You remember that?
Yeah.
You and a friend of you, there were a girl. Oh, yeah.
Also here, Orhan Görbaşı, he's one of the organizers. He is around here. He'll be around here somewhere. Yeah, we did a 100 telescope project, telescope making project, and I did talk about that in Granada, I think, right?
Then I joined a school, 2 schools in Gulhani Park at Fuad Siskin.
Yeah, so it was in 2012.
2014 and 15 I joined actually with some professors. They are teaching over there. Yeah, I remember Mr. Hassan.
Hassan Esenoğlu, yes, he's also a professor in astronomy department in Istanbul University.
Yeah. So I'm happy to join Azarquiel
again,
a school again. Yes. I would like one day I'd like to join it face by face, attend in person. You see, maybe next year. We hope so.
We hope so. Maybe not next year, but at least 2023 it looks more.
Is it held every how many years, by the way?
Well, it differs. I mean, whenever we find some budget and sponsor, we would like to do it. At least it was designed to be a biennial, so every 2 years, but it didn't happen that way. The ideal is to be every 2 years. So.
Good.
But next year, there will be some occasions about the pandemic, so maybe it won't be easy to even in 2022.
Yeah. In 22 here, I am in Qatar, by the way, in Qatar.
You're in Qatar right now, but you are not in Qatar in the beginning.
I was in Jordan at that time.
Yes.
Even I was in Jordan. 2010 it was, I think, 2010.
Yeah.
The first Azarquiel school. Yeah, it was in Granada.
Granada, the first one was in Granada. You attended that one. Yeah. So since then, what have you doing? What have you been doing?
I am astronomer so far. I am doing astronomy. I was working with a program here in Qatar called Qatar Exoplanet Survey. We discovered 10 exoplanets, and they are named Qatar 1B Qatar, 2B Qatar, 3B. Yeah, they are very famous. But the program with the TESS telescope, when TESS telescope was sent to space, we closed our doors, you know, because the resolution is nothing compared to the resolution of TESS telescope. And the fund as well has finished, unfortunately. I'm doing some astronomy Olympiads for the students. I'm the leader of the Astrophysics Olympiad, International Astrophysics.
We're going to start that also in Turkey. We weren't doing that, but we are going to start that, and I will be their leader. So maybe we can get in contact later on about Astronomy Olympiads as well.
Yeah.
Anyway, so exoplanets?
Yeah, now no exoplanets. We are still on the Earth now. No more. No more exoplanets. I am doing the competition for the students here. About 60 to 80 schools are participating every year with the National Olympiad. The National Olympiad is a competition, actually. It is some kind of festival, but we are calling it as National Olympiad. It is projects, 2 or 3 projects carried out by students. Then they have to show their results and outputs and the hands-on in an exhibition, if it is possible. The last 2 years, we couldn't do the exhibition because of COVID-19. But 4 years before that, we were doing this, and 400 to 500 students usually gather at the exhibition to show their outputs, yes, their works. Yeah, and there are some, of course, prizes, medals, and other things, yes. Yeah, but it is okay. It is okay because it is not funded, but sponsored by the Ministry of Education. And as the Ministry of Education is behind that, usually it works. It works. We are doing good job for the level of students. I mean, it's not in the level of astrophysics. Sometimes we teach them astrophysics. We have a team of astronomy and astrophysics, and we are participating in the International Olympiad on Astronomy and Astrophysics. Last time it was in Hungary, and there was a team from Turkey came. Yeah. The first time, it is their first participation.
Yes.
Ours was the 3rd or 4th, I believe. And nowadays, tomorrow, the 14th International Olympiad on Astronomy and Astrophysics is starting in Colombia, in Bogota. Tomorrow it will start, but it is, online competition. That's why we are not participating. And unfortunately, our students have exams nowadays.
Yeah, you're right. Okay, let's. Yeah. By the way, we are on time, so whenever you like, you can start your popular talk about the Astrolab. Why did you choose this topic, by the way?
I am so interested in the heritage. I am now a little bit experienced in the origin of star names, Arabic star names, and how they been derivative and named in the sky, in the charts, in the astronomy programs and applications, mobile and computer applications, and who and how they were fixed to the sky. This is my special interest. One day, one of the Olympiads, the student Olympiads, was talking about Astrolab and the Sundial. So I wanted to break the fear from talking about the Astrolab, because it is a complicated device, and I want to break the fear for audience right now, that don't worry, don't be scared from holding or looking at the Astrolab. I am going to analyze it for you and telling the basics about it, so that if you hold it one day or see it, you would be able to use it and understand how it works. So that Olympiad was talking about the Astrolab, and I was, you know, it was compulsory for me to talk about it. So I prepared a video in Arabic and in English for the Astrolab, and one for the sundial. They are online. Your students might find them on the YouTube.
Yeah, you share me the link. We'll put it on the web.
It will be shared. Yes, I will share it.
Okay.
So I started talking about that, and it was the first video online or on the YouTube talking about the very details, very small details about the Astrolab. Fortunately, I was the first one. Then many other YouTubes appeared on the YouTube after that. So I would like to start my presentation. So thank you very much for having me here today, or this night in this evening. And my name is Hani Dali. I am from Jordan, and I am going to talk about the Astrolab as a device or as a tool, astronomy tool here in this slot given to me. Thank you again. I called it the Renaissance computer. Actually, it worked as a computer because the applications of the Astrolab, maybe you can count up to few hundreds of them. Here I am going to talk about very few of them. Here I am holding one of the Astrolabs, or a model of an Astrolab, which is copied from a real one. Okay, it is a small one because it is personal tool. This one is about 15 centimeters in diameter. The largest one is about 30 centimeters. You might have some 25 to 30 centimeters in diameter. And you might find some smaller than that, up to 10 centimeters in diameter. It means it's just like the watch or something like that. It is personal. Some slides I had from a friend of mine from Iran, who prepared some presentation about the Astrolab. I thank him for that. So the Astrolab is an equipment which can be used to measure and predict the position of the objects in the sky. It also has other uses which could be done by adding different things to it. Actually, too many types of the Astrolab, and the drawings on the Astrolab can do many other tasks. As I said, a few hundreds of them can be done by the Astrolabs. Different types of the Astrolab. This Astrolab, this model or this piece is in Qatar National Library. It is present. We have it here in Qatar, and I studied it and made a short video about it. This is the front or the face of the Astrolab, and here is the back. And this is Moroccan Astrolab because it is. I will show how we can conclude that this is Eastern Astrolab or Moroccan. It depends on the writings, on the alphabet written on the Astrolab. And the man who made this Astrolab, he has said that I have completed my Astrolab in the year, and he mentioned the letters Sharlab. Sharlab, I will talk about what these letters mean. In the Qatar Islamic Museum, we have a good collection. And a few days ago, I finished a course for the guides over there for 5 days, talking about the Astrolab and the sundial and how they should talk to the audience or visitors for the Islamic Museum. They have many, actually, a few tens of Astrolabs. Some of them are presented over here. In the Professor Fuad Siskin collection, I am writing here the link. Someone can take it from here. It is a PDF collection. I gathered few of them here to show that Dr. Fuad Siskin has done very great work for the heritage, Islamic heritage, different kinds of heritage, especially I'm talking about the astrolabe. And the earliest astrolabe was invented, it is thought that it was invented in the Hellenistic world about 150 years BC, and attributed to Hipparchus. Again, Hipparchus is the man who had divided the stars into 6 magnitudes and studied 1025 stars. Then it was further developed in the medieval Islamic world by different and many scholars. The first person credited with the building of the astrolabe in the Arab and Islamic world was reported in the 8th century, and he's Muhammad al-Fazari. In the Islamic world, astrolabe were used to find times of sunrise and sun set because of Islamic applications for prayer and other things. These scholars and technicians and scientists, just like Maryam al-Astarlabi, Mr. Azarquiel, Abu Rihan al-Biruni, Abdurrahman al-Sufi, al-Fazari, and many others, they were working on the astrolabe, and they developed astrolabe, and they wrote books, just like Abu Rihan al-Biruni. He has wrote a book talking about all possible applications or kinds of astrolabe, استيعاب الوجوه الممكنة في صنعة الاسترلاب. And the same thing, Abdurrahman al-Sufi and al-Fazari, and al-Fazari wrote العمل بالاسترلاب المسطح because he was the first to make the flat or the disc astrolabe. And here we have different types of astrolabes. Actually, the first one is the flat one. All of them, most of them are flat, but this one is simple flat. This one, Azarquiel, or called Ashikazi disc, is the complicated one because it doesn't follow a particular latitude. It can be used for any latitude compared to the disc or the flat one, which you have to determine the latitude you are using it. We have both shape astrolabe. I don't have the photo of that. And we have the linear astrolabe. Again, it is used for by some way. I'm not aware of that, but I'm just mentioning the types. And this is a very famous spherical astrolabe. And the spherical is using the globe, while the flat is using a disc. You have to project the globe into a disc to make a flat astrolabe. Actually, it is a disc, but originally it is a globe. Here, the astrolabe itself is a globe. That's why it's easier to use compared to the flat one. The astrolabe is made of many parts. We have the rete, or what we call the map, star map, and we have the plate, and we might have many plates. It depends on the latitude of the location we are using. I'm sorry for the background noise. This is my son is crying. I'm sorry for that, but I'm trying to. He's away from me, but sorry for that. And we have the matter or the mother. Sometimes it's called mother. I'm calling it as motherboard. Okay. Here I am explaining and in details, and you can find that in my video. I'll show you the links. Okay, I'm going to talk about, this is the back of the astrolabe. Okay, the back is made of many circles. The first one, the very far one, the outer one, is talking about the latitudes, or what we call the altitudes from 0. This is the horizon, 10, 20, 30, 40, 50, 60, 70, 80, and the highest point in the sky, which should be the zenith, is 90 degrees. Then you can go down. And we can also measure the depression below the horizon. We can use this alidid or the the rule to measure. And the alidid is aided with 2 pointers. Okay, I'll show you how they work. 2 pointers to point to measure the altitude of any object in the sky. This is one of the application. The second application and the most important application for the LED is to know about to tell us about the date, today's date. Okay, I'll give you an example later on. The second circle, the green one, is the zodiacal signs and the days of the zodiacal signs. Of course, each zodiacal sign is divided into 30 equal days. So this is Capricornus starting from 10, 20, 30. Then Aquarius 10, 20, 30. Then Pisces 10, 20, 30. Then Aries 10, 20, and so on. Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpius, and Sagittarius. So these are 12 zodiacal signs. Now we have the very inner circle is the months. And the months are divided into either 30 or 31 days, or even in February, for example, it is only here 28 days. Okay, so whenever we say that today, for example, I am pointing the alidid here on the day. Let's talk about, this is January 10, 20, 31st. So this is 31st of January, which is coinciding with Aquarius 11th or 12th of Aquarius. So Aquarius start from this line, green, and ends with the next green line. So all of these are the days belong to Aquarius. So the 31st of January is matching the 10th, the 12th of Aquarius. So I need to know this exact information, that the day I am in, what it matches compared to the zodiacal signs. I will give you an example later on. Okay, the front or the disk or the main disk, the rete, or the mother. Sorry, this is the motherboard or the original disk is talking about. This one we can change from one latitude to another latitude. It is showing many things actually. First of all, this is the center of the sky and the rotational center, the axis of the sky. Here is Polaris. So Polaris and this dark or black dash line is the horizon. So how far the Polaris from the northern horizon is indicating the latitude. So these lines are indicating 5 degrees. So 5, 10, 15, 20, 25, 30, 35. So this astrolabe or this disk is made for the latitude of 35 degrees. Okay, so and this is the center of the whole sky. We have one circle, second circle, and the edge one is third circle. The second circle is the celestial equator, this one. This is celestial equator. The first one is the Tropic of Cancer, and the lowest one, the larger one, is Tropic of Capricorn here, Tropic of Capricorn. So this is Madarul Jidi. Okay, and we also have the horizon line, and these are the altitudes, 5, 10, 15, 20, 25, 30, 35, up to 90. So we have these here, these 10, 20, okay, 30, 40, 50, 60, 70, 80, and the highermost point in the sky is the zenith, and which is 90. So I can measure whenever I measure the altitude of any object in the sky, I just put it on the red here, or in the mother, or here the disk. I can measure how high it is, or I put it here to know the time of the astrolabe. Okay, I'll show you. So this is the rete, or what we call the sky map. Now we are using it as transparency. Because it is as transparency, we are using the map. Otherwise, it was supposed to be as, you know, rete with pins, with brass pins here pointing. Each of them is pointing toward one of those stars in the sky. So this is the rete. We changed the rete here. Instead of making pins, we made it as transparency. The whole transparency, the whole sky is rotating about Polaris. As I said, this is Cancer. This is the celestial equator, and this is the Tropic of Capricorn. And the most important thing is the zodiacal signs, this one. And the zodiacal signs circle is, you know, it is intersecting with the celestial equator in 2 points. You know, the first point should be in Aries, the first point of Aries. You know, nowadays it is very close, or it is actually in Pisces nowadays, very close to Aquarius. But let's say that the old one is starting from 23rd of March, this point. So this is the equinox, the vernal equinox, or 21st of March. When the sun is here, we have equinox. And after 6 months, the other intersection in September 23rd. So this is the second equinox. And of course, we have solstice, winter solstice, and we have the other side, we have summer solstice. So this is the very important to know that these are 2 circles intersecting in two points, and the angle between the intersection angle is the 23.5, which is tilt, the Earth's axis tilt. Okay, so the same thing. I will talk about this later. Okay, what are we doing regarding the sky? We have some points, some object in the sky, in the globe, and we are making a projection of that object on the disk. So the first line will coincide with, will be projected on the disk, the second over here, and if we have another object, it will be projected over here. Overall, we can say that any circle or any object in the sky can be projected on the disk. That's why how we make this is the idea of the astrolabe, to project the objects in the spherical sky into a disk. So this circle, which is really in reality it is in the sky, will be projected into this circle on a disk, which is the astrolabe. We will be having those disks. The first one is the zenith, and this is the latitude. That's why they are accumulated over here and they are expanded over here, because they are projection. And this is why, because why we see the oval shape of, as you know, we have something called the planisphere. We use them to locate sky map anytime in the year. So the planisphere window is oval shape. The oval shape is due to the projection of the sphere on the sky into a disk. That's why it gives us the oval shape. Okay. Now, let me tell you about the alt-azimuth coordinates, which I already started with that. This map is taken from the Stellarium web, and here is the zenith. This is the highest point in the sky. And if you take 80 degrees, 60 degrees, 40 degrees, 20 degrees, and 0 degree, the horizon is 0. So these are the altitudes. And these lines, these, they are the azimuth. Azimuth means when we face south, it means we are facing 180 degrees. When we face west, we are facing 270 degrees. When we face east, we are facing 90 degrees, and so on. When we face north, we are facing 360 or 0. So we start from 0 clockwise, of course, from the north into east, south, west. But of course, this the sky, and the sky is inverted compared to the location on there. So this point is matching exactly this point. The zenith here is exactly like here, zenith. And if we look, of course, we are facing south. Otherwise, the north, this Polaris, and this should be somewhere here, over here. Okay, so these circles are resembling or making the altitudes, and those green lines are resembling, or they are the azimuth. So we have two coordinates, and from knowing the position in the sky for any object, I can locate it on the astrolabe, and after that I can talk about the time of that astrolabe. Okay, as I told you, any disk can be done for different latitudes. This one is done for 32 latitudes. This one is for 45 latitude. This one is for 60 degrees latitude. And that's why they are the different disks provided with each astrolabe, because if you move from one city to another city, from one country to another country, you have to change the disk according to the latitude of that disk. But of course, the rete or the map is the same, and this is the validate to fix all these components. Now look at the rete. Of course, we have too many of them, and everyone who prepared or made an astrolabe, he did his own imagination for the pointers on the stars. So these pins are representing stars, and see how many stars we have. 1, 2, 3, 4, 5, 6, about 15. But this is too many stars. Actually, this one is more than 30 stars. It means that it is more precise than others. Okay, these are stars. These are the rates, and we can determine how many stars. This rate is moving, along with the rule. We have to fix the rule to move them all together, because this is the sky motion. This represents the sky, and the rotation of this rete means that the sky is rising and setting. Here the most famous stars used as pointing stars in most of the astrolabes. Most of them are Arabic in origin, except few of them: Sirius, Procyon, Regulus, Spica, Arcturus, and Capella. The others are all are Arabic: Altair, Vega, Danab, Shiat, Sirra, Al-Jedi, Al-Ghul, Al-Dabaran, Rigel, Betelgeuse. Those are Arabic stars, but there are other, maybe about 10 more stars used in other astrolabes. Now, if I am comparing between the front side of the astrolabe with the the figure here, I told you about that, and this is the rete, or the stellar this sky map. I removed it from here. I will put it now in the in some few figures after that. Now I would like to tell you something about the timings. Actually, we are here using what we call the sundial time. In the sundial, this one of the sundials I prepared for Doha, it is 25.2 latitude, 25.3 latitude north, and this is the gnomon, and means the direction of north. And when the sun ray is is showing up, it will give me the shadow, and the shadow will cast on one of the times. You see, this is in the morning, and in the morning the time says it is 9:45. So this is 9:30, this is 9:45. 9:45, this is sun time or sundial time. Actually, to read the watch time, I have to subtract some time called the equation of time difference. So for that September, here I am taking this photo in September 12. In September, we have to subtract 30 minutes from the sundial time to convert it into the watch time. So by subtracting 30 minutes from 9:45, we'll be having 9:15, and this is the time of the watch, which is 9:15. Again, the same thing usually in the sundial and in the astrolabe, the noon time is 12. So the sun should reach the highest point in the sky and midday, noontime, at 12 o'clock p.m., the midday, the noontime, or cultivation, or what we call the meridian time. So at meridian time here, it means 12, okay? But here I'm looking here at noontime, which is we call adhan al-dhuhr, the calling for prayer of Zuhr, noon prayer. It is 11:30. So when we subtract 30 minutes out of 12, it will give me again 11:30, which is correct to, if you want to read any sundial, you have to calculate these values for that city. Actually, these values are calculated for Doha, and it's easy to calculate these values. Just subtract 12 hour, I mean mid time, which is 11:60 minutes, minus the time of noon time or a cultivation time, the time of noon. So just subtract 12 minus this time, it will give you the difference, which is 30 degrees. Use that for all other months. Okay, so by using the equation of time, we can make this table. Okay, so we can subtract from the equation. So the real time, which is the sun time, is equal to the equation of time plus the watch time or clock time. Now, this man who has prepared this astrolabe has used the alphabet to make the date of, to register the date of or the year of making his astrolabe. And he's saying here in Arabic at the end, this is in Kufi font. He's saying وَكَانَ الْفَرَاغُ مِنْهُ سَنْ شَرْلَبْ. Here, وَكَانَ الْفَرَاغُ مِنْهُ سَنْ شَرْلَبْ means we have finished or completed preparing this astrolabe in the year of Sharlab. What does it mean, Sharlab? It means 4 letters: Shin, Ra, Lam, Ba. What these letters? They are talking about the numerals. Okay, alphabet counting, abjad hawas. And when we say Sharlab, it means that Shin here is 1,000, Ra is 200, so 1,200, Lam is 30, 1,230, and Ba is 2. So the year of finishing this astrolabe was 1,232, of course, AD. Yes, AD means that this is Moroccan one, because you see the letters here means the numerals ka, okay. Lam, this ka means 20, ka ha means 25, lam 30, lam ha 35. Meme 40, meme ha 45. Noon 50, noon ha 55. Sad, and this is here the solution. Sad means 60, sad ha 65. And the Eastern counting is different from the Western or the Moroccan counting, because here they are using Sad as 60, the Moroccan, and this is Sad is 60. It means that this astrolabe is Moroccan, while in Eastern Sad is 90. So it's not Eastern astrolabe, that's why. Okay, I will finish with this example, how to apply or how to use the astrolabe. First of all, for today, I have just done these photos a few minutes before I started. So today is November 17, okay? So I take the alidit, the internal line of the alidit, to point on the 17th of November, which is matching Sagittarius, okay? Sagittarius, 1, 2, 3, 4, 4th of Sagittarius, because this is, no, yes, 10, 20, 30 Sagittarius. This is 4th of Sagittarius. So I take the date from the back of the astrolabe. Now I move to the front side of the astrolabe and I go to Sagittarius here, Sagittarius in the zodiacal sign, and take the 4th day of Sagittarius and fix the sun. This triangle, this is some sticker, okay, it is pointing to the sun. So this pointer should be to the sun. So this point is the sun. The sun now is residing on the 4th of Sagittarius. I fix the alidid with the sky map with a sticker so that they together move. They move together. Now I'll take at 12 o'clock midday, the sun here is high in the sky, okay? It is in the center or in the mid of the day. So at the mid of the day, how high the sun is, I can measure that the sun at this time is not far away. It is between 40 and 50 degrees. Look, because we are talking about November. So in November here, this is for Doha, by the way. This astrolabe is for Doha. So the sun is between 40 degrees altitude, and 50 degrees altitude. This is 45, 45, 44. So the altitude of the sun at noon time is 44 degrees. Okay, one more thing. At what time the sun will set? As I told you, we can use okay, this is for Altair. When Altair is reaching the highest point in the sky, I mean the noon, not noon time, the cultivation time, or the highest point in the sky, the sun refers to the time of 15, 20, 40. This is 16. This is 15, 20, 30, 35. So the time here is 1530 time, 1535, when Altair is highest in the sky, which means, of course, 15 in November. Let's go back to this one. In November, we have to subtract again 30 minutes, which means that 15 time here, it is 1535. Our watch will point to 3 o'clock 5 minutes, because we have to subtract 30 minutes in November as well, 30 to 35 minutes. Look at the sun, for example. Sorry for this by mistake. Oh, there was a mistake here. I'm sorry for that. Okay. For example, here, when the sun, we are talking about the sun here. I'm not sure about that. Maybe the other one. Sorry for that. I was preparing it. I was preparing a slide talking about sunset, at what time the sun is setting, but I'm not able to see it. Anyway, sorry for this inconvenience. It was some mistake. By mistake, I missed it. But anyway, at any time we can measure the altitude of any star, and to know the time, and to know when it sets, when it rises, sunrise, sunset, a twilight time, because we have this line is twilight time. This is sunset. The other side is sunrise, and these are the altitudes of any star, and the time of the highest point. What is the altitude? If I measure, of course, we have to fix the day here. If I ever measure a star in the sky, the altitude of any star in the sky, I can determine the other all objects in the sky. So the Astrolab is great. Actually, this is a few of the application of the Astrolab I'm trying to show. Please, if you want to see my video in details, you can please scan this, or I'll put it. I'll put in the.
Yeah, we would like to share all the lectures on the website, so maybe you can send us PowerPoint presentation.
Yeah, so I'll put on the
chat. On the chat as well.
So
okay, that would be nice.
Everyone, this one and another. This one is in Arabic and the other is in English. That's why I'm putting both.
Yeah, maybe some people also would like to see the both of them.
So many other activities. We did many activities in Jordan and here in Qatar, how to prepare your Astrolab and sundial. This is the end of my presentation. Thank you so much for having me to this evening, and I'm ready for any questions. Thank you.
Actually, there about the constellation dial, are there 12, right?
Yeah.
And equal?
Yeah, should be equal because they are zodiacal signs. I mean, the signs used in astrology, not in astronomy. Yeah, you can do your own, actually modern astrolab, and divide it into 13 constellations, including Ophiuchus, okay, and add the days for those and the real sun, and it would give you, more precise measurements.
Do you do any workshops how to prepare such an astrolab that you did? Yeah. That was on paper, right? This
one has we prepared this few days ago. This one was prepared by our friends, and I have other things, these things in my library. Oh, sorry.
No, we can't see that because of background.
I have to remove the background. Sorry for that.
Or put it on your chest. Maybe we can see it. Right?
Maybe. I have to. I don't know how to remove it, by the way. Where is it?
It's in the preferences. Settings of Zoom.
Yeah.
Anyway, just put it on your chest. You see it.
No. So.
Yeah, you can put it on it.
This is one astrolab. This done by students. A third one. This is the quadrant. You see, and many of them actually I don't. So they are done by students, and the one I am holding here was again done by us a few days ago.
So it's a cardboard one, right?
Yeah, cardboard. Yes, cardboard. Yeah.
easier for students to follow.
Yeah, but you know, because it is too many instructions, you have to follow up each and every particular thing and in detail. That's why I did the video for 50 minutes talking about the basics of Astrolab and how to calculate and how to make the calculation. I didn't go through the projection. Actually, projection is another science. You know, how to project the sphere into a disk. I didn't go through this, because you know it was not the main topic for my presentation. I wanted to break the fear from the people who are holding an astrolabe, that this is
how to use it.
Could be read. Yes, that's why. Thank you so much.
You can use it. Yeah, it was very useful. Actually, I didn't even know that much detail. And I know that Azarquiel is the first one who made it possible for any latitudes, right? This one was,
that's why it's
usually
called,
they make it for particular positions, particular latitudes, like Doha,
comprehension astrolabe. Yes.
But Azarquiel did it. I don't know, that's insane. I mean, how can you calculate it for international, any latitude? Even you put another dial for that, that's insane.
You have to go through the old books to understand, or if you find the books which describe these astrolabe, you have to go through them and read them thoroughly to understand. Because as I told you, actually I didn't go through the hundreds of applications, but they are saying that they are more than few hundreds applications for the astrolabe. We can't gather, you know, nobody can collect these applications for 1 or 2 or 3 types of astrolabes. You should have all الوجوه الممكنة, possible applications or possible faces of the astrolabes, or possible types of astrolabes, as El Biruni said.
Yeah, tomorrow evening we're going to have another talk about the astrolabes, and I don't know which one actually, but there's a professor in Istanbul working on how do these things works, and he's going to present one of them, I think. And he's working to
Mr. Majd, maybe he's from Syria?
No, he's from Istanbul. Attila Bir. I don't know which astrolabe he will be talking about, but he's reproducing. So great, he is going to explain the projections.
The second part.
Second part. Yeah, it will be a combining issue. So it was very nice that we were able to get this talk from you, Hani. Thank you very much. By the way, we have 2 questions. Meanwhile, I didn't want to interrupt. So the name of the astrolabe doesn't refer to Mariam Astrolabe, is it? As it was widely known.
She is named after that, and some people say that this is not original name of her. Maybe her father was working with this, or that's why it is, you know, astrolabe means I am doing astrolabe. That's why. But
the people who does astrolabe is astrolabe. Okay. Yeah, maybe she was not back then. Not many women was doing such things.
It is thought that she was bright enough to be able to develop the astrolabe and understand it and make the new shapes or add some calculations, new calculations, which is not available for all people, you know, women or men. Actually, it is hard work.
Yeah, even for both of them, it doesn't matter who does it. But I mean, maybe it was. We're not very sure. We need to read more books, as you say. So are these books you mentioned in the slide available on internet, she says. This is Shema from Algeria, by the way. I will announce her as the most frequent asking question student of the workshop.
I'm not sure. I don't know. We have to look for them. Some of them might be found in some museums. Yes, like Istanbul Museum, Suleymaniye. We might some of these books.
Yeah, but I mean, they're not. You have to get a permission to get a copy of those or something?
Okay, they are sold. You can ask for a copy of that. They can
If
give you
it's digitized,
digital or hard copies.
Yeah, you have to. I mean, not all of them are on internet. I know it's not yet done, but in the future, everything will be digitized. So maybe
the problem with the language, the Arabic, old, ancient language, is difficult for us nowadays. You need someone who is specialist in reproducing the or analyzing the words, because they are Arabic, but you need some specialists to understand the terms. We are using now new terms or different terms, which is hard for me. It is very hard. I have some other friends. They are specialists in resolving these terms. It's easier for them. We ask them usually to please what this phrase mean.
Because it differs in different decades, in different centuries, what people talk about that special term differs from century to century. Yeah.
Because the old scientific language, Arabic scientific language, we didn't follow up. We didn't study. That's why. The language Arabic is Arabic, but the scientific language is difficult.
Changing. Yes, it is changing. Yeah. I mean, for example, tonight we will be welcoming another professor from Kastamonu in Turkey. He is a historian of science. So he's always talking about the same thing. I mean, even in mathematics, they call it a different term. So you have to follow up all the books in that century, even if you know the language, it's not easy to understand what he's talking about. So we'll discuss about that. And even we see that in Copernicus. So tonight at 2 hours from now, we're going to discuss about that. So thanks a lot, honey. It was nice to see you again. And we will be meeting in 2 hours from now. Okay, I mark it answered. Okay, then. Thanks a lot, everyone. Let's meet in 2 hours. See you then. Before 2 hours, actually. Before 2 hours, we will be meeting in 1.5 hours for some social time. So when you have some time, please come back in 1.5 hours so that we can chat a little bit face-to-face on that here before the popular public talk. Okay? Take care.